Here we go. Okay, welcome everybody. Thank you so much for coming to our side meeting on the encrypted IPv6 destination option PDMV2. Okay, so let me just set the stage and then I'll turn it over to the other folks. So this is an addition to PDM version 1 or version 0, performance and diagnostic metrics. It is only for IPv6, RFC 8250. Obviously, the data can be misused, and so we need encryption. And so we're proposing what we believe to be a lightweight and scalable methodology, and the rest of the team will talk about this. And, you know, down the road, if this seems like a good idea, then there's a number of other places where it might be appropriate to use something like this. Other packet headers, IPv6 extension headers, and so on. Things which are not actually going on a different channel, which people seem to be wanting to do these days, ping, traceroute, whatever. So I'm going to go ahead now and turn it over to Ameya. Ameya, go ahead, please.
Yes, thanks, Nalini. Hello, everyone. My name is Ameya Deshpande. I am a student at NITK Surathkal, India. I'll be giving you an overview on PDMV2, explaining how it works, compare it with original PDM, and talk about new things in PDMV2. Next slide, please. Okay. So, okay, so just to give an introduction on PDM, it's an extension, it's an IPv6 extension header. It's a destinations option, to be precise. PDMV2 is the version 2 we are proposing to overcome some of the limitations in PDM and also introduce some new metrics in PDM. So as you can see that PDMV2 provides you two options, encrypted and unencrypted. We received some comments on the mailing list that people will prefer unencrypted and secure mediums, and yes, that option is always there. If if you're using VPN or you're in the company domain, unencrypted is a good option. But for majority of the other cases, encryption can be useful because PDM RFC describes some of the timing attacks which are possible, and it also gives some important data on the sequencing. So yeah. What PDMV2, so with encryption, what we mean is that we have confidentiality and integrity. So the confidentiality part says about the encryption, that it's hidden from the network boxes in between, or any man in the middle who can penetrate in the network. And integrity means that that the destination knows that the data was not tampered with. So these are the two things we try to provide as security in PDMV2. I'll talk about encrypted flows now. In encrypted flows, we have two steps. One is the registration phase, and the next is the data transfer. So the registration phase is a one-time process, and if we consider a one server, one client situation, it basically is a shared secret negotiation. And this registration is will be discussed much more in detail when Mike will explain how it works for large enterprises. About the negotiation, how the shared secret is generated, this part will be also described when we talk about HPKE. So this part is just for the overview, that we have a registration phase in the beginning, and then we have the data transfer. So in a data transfer, generally so what will happen is that we'll form the PDM headers, encrypt it, send it to the destination where it will be decrypted, and vice versa. Again, the receiver will encrypt its PDM headers and send it back, and again it will be decrypted. Again, to note it over here that so I won't be going into details because this will be covered in the upcoming slides. There will be occasional KDF happening. It's key derivation function taking place. I'm just mentioning it and not discussing it because it will be covered properly in the upcoming slides. So for unencrypted flows, it's similar to PDM. There is not much change. Next slide, please. Yes. Okay. So for PDM to non-PDM machines. So this is this slide I'll just cover quickly to cover the case where we are sending data to a non-PDM machine. In this case, we'll have the important information we have is the packet sequence number and the global pointer. We don't have the delta times because there is no last packet received sequence number. So yeah, the global pointers, I think I just mentioned it in a hurry. This is a new field we have. So as I mentioned, we have added new metric, it's global pointer, and I'll discuss it in more detail. So this is the case for unencrypted flow. Even for encrypted flows, when we are using encryption and we are sending it to non-PDM machines, the data is the same in the encrypted form. It won't, I mean, they won't be able to decrypt it in non-PDM machine, but it's possible to decrypt them later if they can create capture files and do it later. Okay, next slide, please. Yeah. Okay, how to use this? So the details over here largely depend on how we are implementing it. Our implementation is work in progress right now, but depending on whether a user wants to use PDM for few minutes or hours, I mean, they can just start the PDM flow and start diagnosing the network. So a user can start a PDM flow with just a parameter whether they want it as encrypted or unencrypted. And again, depending on the implementation, these are some details. Maybe it can be a kernel module to load, or it can be just a kernel parameter. I'm considering the Linux kernel for now. It can be just modified using sysctl. For encrypted PDM, of course, the registration phase should be complete, and there should be the shared secret that should be generated. Next slide, please. Okay, so PDM versus PDMV2 packet layout. So this is the original PDM packet layout, and this is the new one, which we have just shown the unencrypted one over here. Just to recall these fields, we have packet sequence number. This packet is the sequence number generated by this by the sender machine. This is the one which was last received from the destination machine. The delta time last received is the server processing time, and this is the round trip time. If you compare them, so if you directly compare these packets, you will notice a few changes. We have a version number, we have some reserve bits, random number, then a flip bit and a global pointer. So I'll start from the global pointer. The global pointer is used to measure the amount of traffic sent from the PDM node. So this global pointer is initially initialized to 0, and then later we increment it as we send packets to different flows. And a point to note over here, and this is an important point because I think, yeah, these PDM fields which we have, so these are the PDM fields we have. By the way, these are the scale fields I forgot to mention. These are with respect to a 5-tuple, a flow, but the new global pointer we have, it's with respect to the source address type, and the rest of the fields remain same. So this is with respect to the source address type. And we have the link local and global unicast addresses for source address type when we consider global pointer. Okay. Then okay, yeah. So thanks, Nalini, for going to the next slide. So the next the next new fields we have are random number and the flip bit. These are again security related fields. I won't go into much details just for this. So we have just written one liner that it's the nonce in HPKE, and the flip bit indicates the change in the session temporary key. So these things will be covered in the upcoming slides, but these are security related fields. Nalini, can you go back on the last slide once? I'll just show. Okay, yeah. So when we encrypt this packet, basically we have this entire part encrypted. The random number and flip bit are not encrypted. So this is the encrypted part. And generally, so yeah, and when we encrypt this packet, our option length will change. It will increase as we encrypt the packet. Yeah, I think that's it, Nalin. You can go to the next one. Okay. So yeah, that's it. And the version number is just for the user to know that they're using PDMV2. And there are flip bits reserved for future. So this was the overview on PDMV2 from my side. Okay, I'm done, Nalini. Thanks.
Thank you so much, Amaya. So now Mike is going to take over and talk about the topology and why we've done things in terms of that the way we have. So Mike, please go ahead.
Thanks, Nalini, and hi, everyone. Thanks for joining. I'm Mike. I'm the enterprise guy. So we're going to talk about how we can accomplish all this wonderful stuff in a typical enterprise environment. Nalini, next slide, please. What is the enterprise perspective on all this? I think, and most people I've talked to think that the data contained within PDM is going to be wonderful. It's going to be accurate. It's going to be real, efficient, immediately usable. So I think it's something that we're going to want. And it's just network metrics, but in some situations that may need to be secured. So we're going to require encryption more than likely on some session paths, in my humble opinion. For me, as I think about how I'm going to deploy this, I'm thinking that encryption is likely going to be something you need on the open internet if you have connections there. If I'm using this within my network, I'm thinking probably not. I don't want the extra aggravation and overhead, and I don't think it's necessary. But you might, and you might need that even there in certain situations. And then what about other situations like trusted partners, private networks, VPNs? And that's probably on a case-by-case basis. You're going to have to figure out whether you want it there or not. When you do want it, when it is going to be required, you definitely want it to be lightweight, simple, no impact, low overhead, especially on your clients. And probably the biggest area that's going to be a concern is going to be key management. So how can we best accomplish this? Leaning to the next slide, please. And I know this is a little bit busy, but this kind of depicts the overall ecosystem that we think will work out. So let me just go through this quickly and painlessly. In the pink boxes on the upper left-hand side, we have this is depicting kind of a normal situation at an enterprise. We have a whole bunch of clients. On the right-hand side in the blue boxes, we have a whole bunch of servers. The green links between them, those are sessions. We have sessions between our client and servers. No, nothing really exciting there. If we want PDM on those sessions and it's encrypted, we need to have keys and decryption and things going on at both sides. The issue with that potentially is that this could be a performance challenge or a complexity challenge on our clients and servers, something that we don't really need right now. We have enough problems, right, guys? So and I think that that's primarily the big concern is going to be on the clients, because we have way more of them. They don't have a whole lot of extra cycles in memory, et cetera, and they're not in a good position to be managed. And so anything we can do to make this easier would be better for us and make this go in more cohesively into our environments. So what we're proposing is to offload both the clients and the servers with, and now at the upper left and the upper right, and again, pink and blue, is a primary client and a primary server, and the primary client would handle all the keys and decryption for the clients, and the primary server would do so for the servers. Now, if we look at the links, again, we still have our green links that are our real sessions, but the primary client will be talking over the red links to all the clients. And similarly, and some more red links on the right-hand side, the primary server will be talking to the servers, and then the primary client and the primary server talk to each other. So we still have our green sessions, which are the real data. So that's kind of the situation that we see that would probably work well for enterprises. And so let's go on to the next slide, Nalini, if you would. And let's talk about why would we want to do all this? And the answer is we have lots of clients and lots of servers, and they're in different locations. And if we want them all to do this on their own, it could be a bit of an issue. So we want to do something to make that easier for us and for our devices. So if we can do something to help out the clients especially, but the servers as well, that will offload the requirements into this infrastructure and off of our client and server tiers. And again, especially, I think the issue is at the client tier. So is this a big deal? Let's see how and why this complexity exists and why it might be beneficial to offload it. So Nalini, if we could go on to the next slide. And we're going to start out with a ridiculous example. It's what I do best. And that's, let's say we just have one client and one server. Probably not a big issue at that point, because one key and not a big issue. But then again, nobody has a network like this. So Nalini, let's go on to the next slide. And let's say that we have multiple clients, still only one server. It gets a little more complicated. Now the clients need to keep track of things, and the servers need to keep track of things by client. And so it's getting a little bit more complicated. Maybe we can handle this a little bit better on the server, maybe not, but is there anything we could do to make it even simpler for the server? So Nalini, if you would go down to the next slide, and that's where we introduce the primary client. So that's the first box that we talked about on that messy slide. And that makes it a little bit easier because now that the clients can have one key that the primary client will be responsible for. The server only needs to deal with that. And so we've made this a much simpler situation. The problem is this is still not a realistic situation. How many of us have only one server? So let's make the picture a little messy and go on to the next slide. Okay, so now we have lots of clients and multiple servers. Now it's getting a little bit messier. So we still have our primary client, but we have multiple servers. Now the servers need to manage things, and the clients need to understand that they're going to have different keys for the different servers. So it's starting to get a little bit messier, and this is going to be where the complexity starts to creep in, makes it a little bit more difficult for an organization to manage. And in particular, at this case, it's the added complexity is on the server side. So now, can we make it even easier for the server? Nalini, can we go on to the next slide? Okay, so now we've got the primary client and the primary server. This is kind of the high level picture of the very first box that we saw. So now we have a primary client and a primary server, and the keys and the session keys are provided to the actual clients and servers by the primary client to the clients and the primary server to the servers. And they can provide these keys and this support for hundreds or even thousands of actual clients and servers. And I think Nalini mentioned this infrastructure could extend beyond this application, which is PDM, to other applications or other or other data. So that could be a big benefit for a lot of organizations who aren't usually in a good position to accommodate this kind of extra complexity and overhead, in particular on our client tier. So in wrapping up, this infrastructure would allow us to get the great PDM information encrypted if we deem necessary and where we deem necessary, with a minimum of extra complexity and overhead on our existing clients and servers. And that's it. Thanks, Nalini. Back to you.
Thank you so much, Mike. Is that echoing? Yeah. Thank you guys so much. And then if you have questions, go ahead and please put them into the chat window, and we'll certainly stop at the end as well. So now we have Adnan, and he will go ahead and present on the actual HPKE and how all that works, because we certainly didn't know how HPKE worked until we got Tommaso and Adnan involved. So Adnan, please go ahead.
Hi, everyone. My name is Adnan, and I am studying in Florence University and doing a PhD. And I got the opportunity for this draft for the part of encryption. And why we choose the HPKE and what? Okay. As you listen to the Amaya and Michael, that the fields that the PDM version 1, they are very important to manage the network, and the attacker can dream to start a passive attack or the active attacks. So those fields must be encrypted. If they are not encrypted, so attackers can launch, for example, the DOS attack, or he will make a problem in the network management, and the network will work in inappropriate functions. So this is the attacker's dream. That's why we are going to encrypt those important fields in the PDM. Next slide, Nalini, please. And for this reason, we consider two important requirements. One is the data confidentiality, and the second one is the integrity. And for both of them, we need encryption and hash algorithms. And for now, we are more focused on these two security requirements. And later on, we will also discuss the authenticity of the data and the users. We will see it later on in our next drafts. Please, next slide. Okay, so what is the HPKE? Is the hybrid public key encryption, and still is they have. It's not mature to become RFC. It's still they have the 10th draft online. You can see what is the HPKE basically from the traditional encryption. So in the traditional cryptography, they use to encrypt the symmetric key with the public key. But in the hybrid, in the HPKE, what they are doing, they generate the symmetric key with the encapsulation with the public key. And I will demonstrate this later in the pictorial diagram, so you can understand. So the next question that we faced in the mailing group, that why you use or what is the HPKE? So people they don't know about this, maybe the newcomers. So the reason behind why we choose, the first thing is very robust as compared to the traditional one, and it's very flexible for the users, and of course it's efficient than the traditional, because we are in touch with people, they are using it, and we got those comments from them even, and we are also doing internally our practicing. So we tailored the HPKE framework for the encryption and the decryption. So HPKE actually is a it's a framework. It's a big suite that includes the KDF. It's a key derivation function, and the CAM, key encapsulation mechanism, and authenticated encryption with the associated data. So these three variants already are standard, and they have their own RFCs. And so that's why we choose, and is the more description of the these variants I will show you in the next slides. Naren, next please. So how this thing is more flexible for the users, as you can see here. So the CAM, let me turn on the pen. Is it? Yeah. It's up here. Where is the pen? Okay. So as you can see here, the CAM is the RFC 5869. So it's already standardized, and 7748 all they are using to drive the key to encapsulate with the primary key, public key, sorry. So, and on the other hand, the AEAD, so they is also using in the Google is using also they have a Cha-Cha 20 poly protocol in RFC 8439, and also the KDF with the 5869. So these are already standardized that we adopted. And how is flexible for the user? They just need a suite with the CAM ahead and KDF by choosing these values from the value column. So this is what we have from the HPKE framework, and we are in process of doing experiments by using different protocols that of the encryption and the hashing algorithms. Nalini, next please. So for the PDM, the CAM is used only once. It is used to transfer the master key between two entities. In our case, is the primary writer, both side the client and the server. And the KDF is once in a while this protocol will be used, and the ahead is for the every packet that is a normal that we are using. Next slide, please. Okay, so the key encapsulation mechanism, if you see here, the receiver public key is used, and there is some context like info, and the sender is using its private key to, and this is the encryption part, or you can say the authenticated encryption, and the output of this function will gives you to the symmetry key and the encapsulation encrypted key. And this mode is the authenticated mode, but there are 4 modes that presented in the draft, and we are following this one because we are more considering the authentication of the key. So the next slide, please. Okay, in the key derivation function, so we have the input key material like the master key, and we can put salt, and this extract function gives you the pseudo random key. Basically, the KDF function is you have one key and you need multiple keys for different sessions. So this function, the expand function, use the output key material. This is the session key, for example, K1 is here, and the L variable gives you, it tells you what is the output key length. So the basic goal to adopt this is to generate many keys for our multiple sessions. And this one, as Amaya told you, there is a field that was unencrypted, the pseudo-random number with the flip bit. So it will create a next key after this value returns 0 or change. Next slide, please. So in the authenticated encryption additional data, so this function is used for each packet. Okay, and in this we have a seal function, and this K can be the session key, and this is the associated data and the nouns, and this is a plain text, and this seal functions gives you the ciphertext. And on the other hand, we also need these values to decrypt the data. But here is the associated data and nouns. We are using the pseudo-random number as for the nouns, and each the flip bit that the Amaya told you in the header explanation, that the key will rotate. It will the sender will explicitly tell to the receiver that we are changing the key. And for the nouns communication is also the both parties can knows with some other way, or you can transmit through the ciphertext. So this protocol already standardized in the 5116 RFC. Next slide, please. So HPKE in our PDM version 2. So in the registration phase, we are using CAM. So it will help us to share the master key. And the online phase, as I told you that every 2^15 packets, the KDF function will be called, and the pseudo random, which is the nouns. So they are we are in discussion right now that we will do it on a runtime generation or pre-generation. And the third thing is the AEAD, the algorithm. As I told you that it's also online phase, and it will use for the encryption and decryption for each packet. Next slide, please. Okay. Any questions?
So let me go ahead and take control back then. Thank you so much, Adnan. So any questions from you guys as to how this, what we've been saying? And I know we told you a lot of different things. So while you're thinking, I can unmute you. Go ahead. I think you guys can probably unmute yourselves. And so feel free to go ahead and ask. Otherwise, I'll kind of chat a little bit about what we're doing. Is right now we're working on a prototype implementation for this, and I hope by next time in Madrid that we will have an implementation which which can do this. We already have PDM in the Linux kernel, but we don't want to release it because we think there are enough security issues. Okay, so I see a question here. Okay, so the question is, how are the sub-key clients derived? If I compromise one client, can I read the traffic from all the others? Let me give that to Tommaso and Adnan. Tommaso, yeah, go ahead.
Actually, no, because the key derivation function is a function that will take into account we didn't show because we can't show everything, otherwise you will be overwhelmed, but we are inserting in the key derivation function also the IP and the port numbers of the different clients and of the different flows. So if you compromise one session, no, you will not be able to compromise the others. Of course, assuming that the key derivation function is right, but again, we are using an RFC already well proven, so we can trust it. Until, of course, contrary proof, but in that case, a lot of people will have an issue, and probably we will have another RFC included in the HPKE right away. So we are kind of confident.
So there's a follow-on
And no,
question.
if I compromise your client, if you compromise one client, you can access the master secret. Yes, that's a big point that we are discussing about. The client shall be not compromised, but of course, if you are at risk of that, you can also redo the setup phase and have another key, of course, not communicating it to the compromised node. Yeah, we are discussing about that as well. So to introduce a key derivation function to send the key to the client, so each client will have another one. There are some inputs that we need to have. The part where the master give to the secondary, the primary goes to secondary. The key is still under discussion, but that's a very good point, and we will for sure take it into account.
Yes, Jonathan, that's very, yeah, no, that's excellent. Yeah, maybe everybody gets a separate key, and it's the main guy. He's the only one that has the complexity. And so if you compromise one, then you've only been, then there's only one guy at risk. Okay, so this is great. Thank you guys so much. Okay, so then now here's another question. I guess if you want to chat, can you guys not unmute? Because I think maybe I can unmute you, but anyway. So, okay, so another question. What is to prevent man in the middle from subverting the registration phase before any PDM data has already been transmitted? That's a good question. Yeah. Tommaso, any thoughts on that? So you're
well,
saying
it depends. If you want to, yeah, it depends on what kind of registration you're doing. If you're doing a registration with HPKE using certificates, actually the answer is no, because you will rely on certificate, and hopefully the server and the client will verify that the certificate has not been compromised. Of course, you could revert to weaker types of authentication, like with a shared key, because HPKE allows that. But again, there are drawbacks, like the one they say, the man in the middle could actually subvert the registration phase. So
yeah, we didn't guys. Yeah, that's really good, Rob. We didn't talk about authentication. I mean, because you'll notice we left that out, and I think probably that's, because as I said, this was enough as it was, but that's probably something that we should have in the registration phase, is to really discuss authentication with that. Yeah, really good point, Rob. Any other thoughts?
And the other thing, the random number that you're submitting that is not, sorry, this is Rob again. The random number that you're sending is in the clear. Is it not possible for somebody watching the transmission to be able to mess with some of the encrypted data at that point? And we're saying no, because the two partners in the conversation are the ones that have the right secret to be able to decrypt that data using that random number. Is that how that works?
yes, no. The random number is actually part of the nonce. The nonce is needed for the decryption. It is checked for integrity during the decryption. It's there because we don't want to use a sequence number. We could have used a sequence number, but then the flows would have been trackable. So that random number is not really revealing any part of the secrets. And it's safe to have it in clear text.
So Rob, basically the answer is, I think it's kind of it's one of those, there's more to it than, you know, that kind of an answer, because it's actually quite complicated. You know, you need a group context, this, that, and the other thing. Yeah, Adnan has.
This is the detail. This is the detail of nouns.
Yeah. That's the detail of the nouns. He's put that down. And so, guys, you know, this one of the things that I'm going to say too is, like, we meet every Friday well, we have a meeting every Friday just to get ready for this. But in the future, I think, you know, on a continuous basis, we will meet probably every other Friday. And anybody who's really interested, we encourage you guys to join the group. Just send me an email, you know, and then please feel free, because you can see everything, you know, evolve. You can see Amea's code. You can go through code walkthroughs. Doesn't get much better at that, guys. And because it's you know, there's this whole group context and stuff. You know, there's a whole lot more involved. I know Adnan wants to say something. Go ahead, Adnan.
Yes, there is one question or statement that Jonathan told, that the main client could give each client a unique key. Well, the main is if you're talking about the main client, the primary writer, well, between the primary writer and the readers, we are not there, but we have some light that we have seen in the draft. They are using the pre-shared key. Okay, so we are not at that point right now, but we can use the pre-shared key along with the symmetric key or the session key, derived session keys. So we will consider this thing as the Michael explained the ecosystem. So if you see the red links, so you are talking about those one, if I'm not wrong.
Yeah. No, guys, this is yeah. No, thank you guys so much for your great questions. Anything else? Otherwise, you know, as I say, we'll put out there on the IPPM email list our bi-weekly meeting things, and you guys please feel free to join us. We'd love to, you know, because that way you can, you know, I mean, it's a lot of fun, but then also too, you know, everybody stays on track, and then we can learn to improve. We can really improve the, you know, all the, you know, improve the draft. So great. Thank you guys so much. And we are recording. And so ideally I should get the recording after this, and we'll make that available to everybody. So thank you guys again.
How much time do you have left?
We have about 15 minutes left.
Okay. Did I'm just getting started on my questions here. How often
go ahead.
Are you,
knock yourself
how often are you changing the keys between partners here? Are you, having written some of this stuff myself before, I just know that regularly I was ordered to make sure that we change the values for, you know, because we were doing symmetric key encryption. But how often? It looked to me like you were saying about every 32,000 packets that you send. Does that sound right?
Yeah, it's 2 raised power 15.
Okay.
32,000.
32,767,
Yeah.
right?
Yeah.
Okay.
Hey,
How do
Rob,
we
Rob, do I get to ask a question on your question? How
go
do
right
you
ahead?
feel about it? Well, I was going to ask what your reaction to that was. Is that an adequate number? Do you want some flexibility there? Does that present any issues, that kind of thing?
This, well, there are a couple of scenarios that I'm thinking about here. One where we have extremely short sessions, or sessions that usually are extremely short, and those are never going to hit that many packets. I'm just tossing it around in my head at this point.
But Rob, that, because remember the 5 tuple is a part of this. So unless they're reusing the 5 tuple, you'll inherently get a different key.
Right. Nope, that's good. I understand that.
Yeah, and we can also make that a parameter, right, Amaya? We can make that a, because that can be an implementation specific thing. It's like, do you want to? Because I think that was like the max, right? But we can make it lower too. It's like, are the users set?
And Rob, that's where I was going. I know in some of my situations, I would, and I hesitate to bring this up now because we got to crawl before we walk, right? But eventually,
right, I understand.
When we get to near deployment time for this and everything else is resolved, it'd be nice to have that be a parameter because different sessions have different requirements, et cetera, just like you were starting to point out. So, yeah, that's why I asked you. Thanks.
And that's very, my own situation. I said, I really want to exchange exchange a new set of keys every 5 minutes at least. But client said, no, that's far too often. Our routers only do it every, once a day or something like this. I'm like, no. So something more often, something between those.
Yeah. Let me jump in with just a consideration. Sure. The 32,000 packets is a limit, is an upper limit due to the length of the nonce that is 16 bits -1. So sure. That's the upper limit where we must change the key because standard does the encryption standard does impose that. You can do whatever you want before, and for the master key, that's an administrative problem between the primary reader and writer. They can change their master secret whenever they want, provided that they communicate it to the devices. So.
Okay, the thing that got me first was none of the operating systems that I work with are anything like Linux. So having to modify it, it sounds like when we're talking about a primary partner here or a primary server, primary client, in my instance, that would mean that's the IP stack itself. And he is the guy, or maybe a policy agent or some such, who's kicking off PDM for us. And that's why so I wasn't able quickly to, match the scenarios you were talking about, Mike, with, the environment where I'm working.
But Rob, I'll let Mike get a word in edgewise. I know a little bit about Rob's environment, but Rob, you could have, you could have like Linux on Z. That's for sure. For sure, you can do that. And we're putting it into the Linux. Yeah. And 2, you can have something offline too. I mean, these days, just because it's on the mainframe doesn't mean that it's out of the picture. And number 3, it's like after you get real familiar with HPKE, and this is just like day one, you know what I mean? Because we've heard this, you know, Adnan do these presentations, you know, like for hours, and then it sort of started to sink into my thick skull, some of these things. Yeah, it was tricky stuff. But then maybe we can pressure IBM. And then now, Mike, I know you want to say something. I'll let you get a word in edgewise.
No, you pretty much said everything that I was going to say, and then I was just going to say thank you to Rob for pointing that out. You know, and there's a reason that we're starting on Linux. So you guessed that in a hurry. But yeah, we need to know what, you know, and that's supposed to be my job. So thank you for doing my job better than I do. That, you know, to figure out what.
Oh, happy to help there, buddy.
Yeah, and I need lots of. We all need lots of it. But you know, to figure out what deployment issues that we're going to have, and you just outlined some. So keep that good feedback coming. Thank you.
You know, I'm working with the policy agent right at the moment and doing all the configuration there. And of course, there is some ability to say, sometimes I want to skip that PDM destination option. Sometimes I don't. And so first off, I was real happy to see that, but I really maybe that might be where the implementation for PDM goes. I'm just trying to picture how I might put that into my environment. Beyond that, you know, I might have to code up how HPKE works myself if I want to get it to work on VMs. So I don't know yet.
Well, we need to. I have not started pressuring IBM to implement PDM at all. And as I say, because it makes me nervous with all the problems that I know are possible, you know, with the timing attacks and so on. So, but once we get all this, once we get it secure, then yeah, then I think we begin the pressure campaign for implementation, and on Windows too, because we need the information. So what else you got, Rob?
No, I'm good with that. And obviously I need to join you on your Fridays to chit chat with you guys as well.
Oh,
and I do have another presentation ready for you. So I'm just passing it past our marketing folks to talk about implementing IPv6. So we'll be talking anyway.
no, that's great. So guys, we have the IPPM in like 5 minutes. So thank you all so much. And then I will see you, probably all of you, at IPPM then. Okay.
Yep. Thank
Bye.
you very
Feedback,
much,
everyone.
everybody.
Thank you so much.